I have too many projects. Too many car projects that are not finished. So perhaps it's a little short-sighted of me to take my one finished car and keep demolishing it in the desert, but here we are. When we last left the 4Runner, it had a few more things it needed done, including changing the oil and fixing the brakes. I decided it would be a good idea to just cross those off the list and move on with my life. This is, by the way, not a good idea, and I did eventually do them. The oil change was mundane, but the rear brakes were done at just the right time.
It's only a wafer thin.
You might be asking why I would let my brakes get that low before changing them, and to this I say, it's called getting your money's worth. I also got my money's worth out of my engine mounts. You see, many weeks ago I noticed a clunking noise coming from my suspension. A quick look around the car revealed a suspension bolt that was half missing, a cracked shock tower, and later a bushing that was, not there. So after replacing all of these parts, really all of the suspension wear items, the clunking noise was still there. So I went off-roading 3 more times and then resolved to find the noise. Some of my off-roading buddies mentioned that they had replaced their engine mounts twice already, so I shoved a GoPro under the hood and drove around in first gear, mashing and unmashing the throttle. You can see the frame here with the top of the upper control arm, and here you can see the engine. It's not supposed to move this much. So I shoved a floor jack under the oil pan, lifted the engine up, and removed the mounts. The right side was okay, but the driver's side was 2 completely independent pieces. This is bad, but a somewhat easy fix. So with the 4Runner back together, I took the car out to the deserts of Arizona, where one of my off-roading buddies obliterated his front differential.
That's really bad.
He was trying to crawl over some rocks, and once his spinning tires caught grip, the sudden load was too much for the ring gear, and loud noises were heard. This was especially frustrating since a few weeks ago, the same guy in the same car had the exact same thing happen. Apparently the weak point on the front end of a Lexus LX is the ring gear. The 4Runner has a different weak point on the front end, which I found out a few weeks later in Gorman, California. If you've ever been off-roading in Gorman, you probably know this hill. It's on a trail called Pronghorn, and it's pretty steep. There are several paths you can take up and down the hill, each with its own challenge. I took a pretty aggressive route down, banging the frame on the rocks. It's fine, that's what frames are for. My fellow off-roaders took a more practical line, which was less exciting, but also less damaging. The rocks here are very sandy and very slippery, which makes it unnerving to try to drive down slowly. It also makes it difficult to drive up slowly. So I drove up quickly. My spotter was at the top telling me which direction to go, and I was in the driver's seat mashing the throttle and ignoring most of his input. Until his input was mechanical failure. My buddy at the bottom of the hill with the camera was a lot more enthusiastic, especially right at the point of failure.
Yeah! Oh no!
The differential did not explode, thankfully. The tie rod, however, did experience what engineers call buckling. This is an expensive hobby, and I'm not sure how I'm going to pay for all of these repairs. Maintenance is not always fun, but it is necessary, otherwise your car will stop working at inopportune times. Your body also needs maintenance, and I'm a lot better at this, partly because it's more important, but mostly because it's way easier. Every morning I shake up a scoop of AG1 with some water to start the day with hydration and a full spectrum of vitamins and minerals. My mood and energy are affected a lot by what I eat, and I don't spend a lot of time looking at nutrition labels and adding up vitamins. I'd rather spend my time on the trail or in the garage fixing what I broke on the trail. AG1 is a comprehensive nutrition supplement that makes it easy for me to get the vitamins and minerals that support my immune system, keep me energized, and improve my focus. AG1 sources the highest quality ingredients it can find. It's gluten-free, dairy-free, paleo, vegan, keto. I have been using it for years, which is part of the reason that I am in better shape than my vehicles. Give it a shot, see if it works for you. Go to athleticgreens.com/superfastmatt and get a free 1-year supply of vitamin D3 plus K2 and 5 free travel packs with your first order. Buckling is pretty well understood. If you pull apart some steel at some force, it will tear apart. That force is dictated by this equation. If you push steel together, it will fail at about the same force, depending on the alloy and a few other things. But as a piece of steel gets longer and skinnier, it might fail in buckling before it gets to that force that causes it to tear. This is a classic gotcha question in engineering. You ask a question that sort of implies the part will fail from its ultimate strength, and you see if your engineering students remembered to calculate for buckling. This failure is a classic buckling failure, and we can pretty easily calculate the force that was applied to this tie rod to cause it to go all obtuse on us. This is the buckling equation. The only part of this that makes it more complicated is the fact that this part has different diameters. It bent at the smallest part, which is expected. If it failed like this, then all we would need to know is this diameter, because this would just be a weakest link failure, but buckling depends on the whole part. To calculate this number, I just sort of averaged out the diameters and pretended like it was all one continuous rod, but this is the wrong way to do it. There are 3 ways to calculate this. One is with math. You can calculate the contribution of each section to buckling. This fat part doesn't contribute very much. This part probably doesn't either since it's short, and we can probably just ignore this entirely. For the threads, we can use the root diameter, but this gets complicated since the geometry is not simple, and also I don't want to do this because math is dumb. The second way to do this is to just use a chart from a simplified geometry. We can pretend that some of these diameters are the same, plug in these lengths, and use this chart to get a pretty close approximation. I like this approach because it's way easier, and practically speaking, it's probably going to be about as close as all that difficult math. The third way to do it is to draw it up in CAD and just do a finite element analysis. This is the best way because it's the easiest, it's probably the most accurate, and it requires literally no math. I'm just going to go with this averaged number here, even though I said it was the wrong way to do it. If one of you nerds in the comments wants to do it the hard way, we can compare notes. Here's the weird thing. When the failure happened, not a lot was going on. I was mashing down on the throttle and I was in low gear, so there was a lot of torque at the wheels. And since I 3D scanned my 4Runner front suspension, I can look at the geometry of the steering, calculate the torque at the wheel, and then calculate the resultant force pushing the tie rods together. Even if you assume the traction was all on the outside of the wheel, and even with an impact load of the spinning tire hitting the ground, the force at the steering rack is not that much, not even close to the buckling load. So I backed up the video to see if I smashed a rock with the tire, but nothing. So I backed it up some more, but nothing. Then I backed it way up, and there it is. Let's see that again. This impact here is what buckled the inner tie rod, and none of us noticed. So for 2.5 minutes, I just mashed on the throttle, bending that poor tie rod back and forth. It's amazing that it didn't break altogether. It's not surprising that it buckled. This is definitely enough force to fold up a tie rod. To buckle the tie rod, we can calculate that the tire hit the wall with a force of at least 8,500 pounds. Seems reasonable. It was a good whack. What do we do with this information? I don't know, nothing. We could beef up the inner tie rod with a welded sleeve or just replace them with larger diameter parts, but this is a bad idea for reasons I will get into in a moment, right after we talk about getting into this precarious situation was fun, but getting out of it was very nerve-wracking. Hammering the throttle uphill got me into a position that made it hard to back down. Making it even harder to back down was the fact that I had no steering authority. I could suggest where I might want the 4Runner to go, but it was going where it was going. My right rear tire was approaching a ledge, and my left rear was falling further down the hill. Every time I backed up a little bit, the vehicle would tilt farther to the left. All I needed to do was get my right rear off the ledge, but every time I inched closer, I tilted farther to the left. To make things worse, since I had gotten out of my car to look at the steering situation, and since the car was angled so much, the seatbelt retractor was locked and I couldn't put my seatbelt on. So a buckling failure had resulted in me not being able to buckle. I rolled up the window to add some possible protection, and I had a death grip on the passenger seat. I got as far over as about 45 degrees, which if you had asked me before this trip, I would have assumed was too far. It was past the comfort zone, beyond the pucker zone, and well into the brown zone. I kid, but this was actually super dangerous, legitimate possibility of injury or death, especially without the seatbelt. If I would have known that this would have led to the car leaning this far over, we would have made different plans. But I was so close to the edge of that little ledge, we just needed to go a little further. Thankfully, the rear tire finally came off the ledge. At the bottom of the hill, I inspected the bent tie rod to find out that it had straightened itself out a little bit, which was not expected. But it was enough to drive through the dirt to the pavement and call AAA. We got lunch, and an hour and a half later, the truck had not only not arrived, but they hadn't even found a tow service yet. I called around to local auto parts stores to see if anybody had an inner tie rod, but no luck. I do have a 2-inch receiver on the smart car, and I considered getting a ride home with one of the other guys, renting a tow dolly, driving it back to the 4Runner with a new tie rod, then using the tow dolly to tow the smart car home. In the end, I just cranked the tie rods until the front wheels were mostly parallel. Took the car out on a side road for a test drive, slammed on the brakes a few times, and called it good. I drove home in the slow lane, keeping it under 50. Los Angeles traffic made this real easy. With the car home, I ordered new tie rods, inner and outer, for both sides. This was an easy fix, except for that one of the tie rods looked different than the other, even though they were the same part number from the same company. But also the bag inside had a Napa part number inside a Moog box. Whatever, it's probably fine. The ID of the boots was a lot smaller, but I got it smashed on there with a liberal application of grease. I gotta stop buying car parts from Amazon. I did consider buying beefier tie rods, and they do sell them. You can also buy sleeves that go over the tie rods, making them less likely to buckle. I decided not to do this because a tie rod failure is a relatively easy fix. It's a mechanical fuse that's a lot easier to replace than a broken upright or a failed steering rack. In fact, apparently the factory service manual calls for the entire engine to be removed to get to the rack. There are DIY guides that do it without engine removal, but it still looks pretty serious. If I knew the force required to cause failure in all the other parts of the system, I could maybe add stiffness to this tie rod while still keeping it the weakest link, but I don't know how strong everything else is. And for all I know, this little narrow spot is here for this exact purpose. Anyway, engineering didn't answer any questions. It helped us in no way, and I have learned nothing. But I didn't die, and neither did the 4Runner, despite all the odds. We both live to die another day. Despite all my efforts to keep the 4Runner in pristine condition, it keeps trending towards disaster. This might be partly my fault. I still need to put some rust inhibitor underneath. Hulavator had a lightsaber failure, and also I forgot to secure some 2x4s I was hauling, and an abrupt stop sent one flying into my windshield. I also need to clean my windshield. So we have crossed 2 things off the list, but we have added 5 more things, 2 of which have since been finished. Also, I need to get an alignment, which I probably should have done after I swapped out the front suspension bushings. And so we will keep doing this 1 step forward, 2 step back thing until Toyota finally comes out with a new generation 4Runner, and I can buy one and enjoy the wonder of a perfectly unbroken vehicle for all of about 5 minutes before I roll it backward down a hill. Thanks for watching.